Good day, this is Professor Russo. We are reviewing Chapter 8, putting some problems together. I provided you this worksheet and the answer key, and now I'm providing you also the video of how to get the solutions, and hopefully you'll be ready to take that assessment in a couple days. So, the goals of what this whole unit is about are pretty much there at the top, right? So I'm going to give you an example of each one. Finding the domain of a rational function. Okay, we kind of do that differently than if we were finding the domain of a quadratic function. We're going to be talking about reducing or simplifying, kind of like reducing a fraction, multiplying and dividing fractional expressions. Fractional kind of rhymes with rational, and that's what they are. We'll add and subtract some rational expressions, the ones that have a common denominator. And in this video, I'll show you how to add and subtract the ones where you have to find the least common denominator. Solving equations that have a single fraction on each side. Those are very easy to solve. And the ones that require a little more thought, solving an equation where you have to find that common denominator and multiply both sides through to solve it. I've also provided a video, or another YouTube video, not mine, on the work application problem, and I will go through the work application problem that I provided as an example, which follows that YouTube video. You should watch the YouTube video first. So let's begin with example number 1. Find the domain of the function. Okay, well, the domain, we'd love our domain to always be all real numbers. What that means is I could plug in x, any number I want for x on the entire number line, all the way out from negative infinity to positive infinity. And that is pretty much true, except we're going to denote or list the exceptions. So we do this one a little differently when we have a fraction. So just remember that when we take a regular old fraction, right, it's okay to have the number 5 over 7. It's okay to have the number 0 over 7. It is not okay to have 5 divided by 0. That is undefined. And that's because in the denominator of the fraction, we have 0. And whenever we divide by 0, it's just not a real number. The calculator will give you an error message. So when we do the domain of a rational function, it really doesn't matter what's on the top of the fraction, but the bottom of the fraction cannot result in 0. So what you do is you try to go find the exceptions that make that 0. And you say, hey, this is what x can't be. It could be any other number on the number line except these. So remember, we cannot have the denominator result in a 0. So actually what we do result in 0, not result in result, sorry, result in 0. So we actually take the expression that's on the bottom of the fraction and we set it to what it's not supposed to be. We set it equal to 0. And so we solve it. Like we did in the previous couple chapters, we factor. Looks like it's got to multiply to be 32, add to be 12. Okay, those are both negative. X equals. So each parenthesis individually, if you remember, set equal to 0. When I set x minus a equal to 0, x equals 8, okay? And the second time around, I take x minus 3, and I set it equal to 0. And when I do that, x turns out to be 4. So when we're solving a quadratic, that's actually what we came up with, those two answers. However, these values make the denominator equal to 0. So we say this, that the domain is all real numbers except 8 and 4. And we write it like this. the x, the domain, the x, cannot be equal to 8 or 4. And usually you'll see it like this because the not equal to sign is kind of a tough one for my Open Math to write. So they use NE, not equal to 8 or 4, when you're working out those problems using their answer format. Okay. Example number 2. It's not asking us to find the domain. It's not a function. Notice the first one was a function, right? It had f of x equal. We find domains and range of a function. We're not worried about the range, by the way. So this is not asking us to have a function. It's giving us a plain old algebraic fraction that it wants us to reduce. It's like us trying to reduce the number 3 6. We say what numbers actually go into 3 and 6 at the same time. We divide them out and get a smaller number like 1/2. That's what we're doing here. So we're going to divide out. However, we cannot divide right now. We can only cancel between multiplication signs. So I've got to produce some multiplication in the numerator and the denominator. Well, that's just another fancy way of saying we have to factor. So let's factor the numerator. You take out a 4, the greatest common factor. That's all we could do. Leaves us with x plus 2. Let's reduce the denominator. Oh, that's a quadratic. That's a 3-termed expression. It's got to multiply to be 20, add to be -8. We know it's got to be x and x. And it turns out to be -10 and plus 2. So we factored both the numerator and the denominator. And now we look and realize that we do have multiplication symbols. Factoring makes that multiplication. And therefore, I can cancel that entire chunk, that entire factor of parenthesis x plus 2. And my final answer will be what did not cancel, 4 over x minus 10. When multiplying two rational expressions, we don't want to try and do the distributive property or anything like that. We want to, if at all possible, once again, produce factors. And once we produce factors, maybe some of these things will cancel out a little bit. It's like taking the number 2/3 and 6/9. Instead of just multiplying straight across, maybe I can crisscross reduce. 3 goes into 3 once, and 3 goes into 6 twice. And then I can end up with 2 times 2, or 4 on the bottom, and 1 times 9, which is 9. So I kind of crisscross canceled or canceled up and down, so I need to, again, the most important skill we can do in this course, we have to know how to factor. So I'm going to factor that numerator of the first fraction, and that numerator, all I could do is pull out the greatest common factor, which is 2. I'm left with x minus 7. On the denominator, again, I have a quadratic. Okay, so it's going to go to the double parentheses with x and x. It's got to multiply to be positive 35 and add to be 12. So that looks like a minus 5 and a minus 7. All right, and now I'm going to multiply that. I'm bolding that multiplication symbol times the second fraction. And when we look at that second fraction, we'll do red. This numerator here, starting with x squared, is going to factor to double parentheses. X and x got to multiply to 30, add to be 11, -5, -6. Okay, and then the bottom also is going to factor. Oh, that's a difference of 2 perfect squares. We see that 6 times 6 makes 36, and it only has 2 terms. So we remember that if it is multiplying to be negative, one has to be plus, one has to be minus. we see that magic number 36. That means it started out to be 6 times 6, and x squared starts out to be x times x. And now we have factored example number 3. And now we cross-reduce or cancel up and down as well. So I'm going to cross-reduce with the green marker, x minus 5 there and x minus 5 there. I'm going to up and down reduce x minus 7, x minus 7. And on the fraction on the right, I'm going to reduce x minus 6 with x minus 6. So what is left out of all of this? I basically ran out of colors except black. So I have a 2 that is still remaining that did not get canceled out. And on the bottom of the fraction, we have this x plus 6. That's the final answer. Don't try to reduce the 6 and the 2 because it's not between factors. It's not between multiplication signs. It's between plus signs, and we don't cancel between addition or subtraction. So there's our final answer in that question. On the bottom of the page, I said I'm not going to give you a division problem. It will be on the assessment, but I'm not going to review it because what you do is you take the division and you convert it to multiplication. So if I had something like 40 over x plus 2, and I divided it by 3x plus 6 over, nope, let me change that. I'm making it up as I go here. 8, let me erase that. Sorry, find my eraser here. Let me get that out of there. That's what I get for trying to tell you I'm not going to do it, and then I give you an example, and I actually do it. So let me clean this up, and we'll come right back. So now I wrote it to the way I wanted it to be. We'll do this one example. Here's the important thing to remember. It's very much like the multiplication, except we have division. We want to convert the division to multiplication and do it just like we did example number 3. I just can't convert division to multiplication unless I change something else to compensate for it. So we flip over, invert, use the reciprocal of the second fraction. And now, if I want, I can cancel. However, I probably should do a little factoring here. So let's see what I get. I'm going to leave the 40. I'm going to leave the 5. X plus 2 can't factor. The only thing I can factor is 3x plus 8. I'm going to take out a 3, and I get x plus 2. So now let's use the green marker and see what's left. I can cancel crisscross. 5 goes into 5 once. 5 goes into 48 times. And this whole x plus 2 expression cancels with this whole x plus 2 expression. This final answer turns out to be, what do I have left? 8 times 3 over 1 times 1. So I have a final answer of 24. 8 times 3 in the numerator and 1 in the denominator. The important thing I wanted to show you is that if you see a division problem, just change that division to multiplication and make sure that we reciprocal, if you want to write that word there, and make sure we reciprocal the second number, the second fraction, we leave the first one the same. Okay. As we move to the second page, we have addition with a common denominator. So we're going to add these two fractions. They both have a common denominator of x plus 3. So when I add fractions that have a common denominator, I repeat the common denominator in the answer. And I combine my numerator parts together with the plus sign So I've got 7x plus 8x, that's 15x plus 5. So my numerator is 15x plus 5. My denominator is 3x plus 1. I probably think I'm all done, except I can factor the top expression. And I'm going to pull out a 5. When I factor out a GCF of 5, I'm left with 3x plus 1. And oh, lo and behold, I have that same 3x plus 1 on the bottom of the fraction. Therefore, now that I have multiplication between the expressions, I can reduce or cancel those common factors. My final answer to that question is 5. Okay, easy question. It's nice when they have a common denominator. When we look at example number 5, we're going to subtract. And it says, be careful, but you do have a common denominator, right? So this is almost the same as what we see for the previous question. You're going to say, well, what's the big deal here? Okay, I'm going to put that minus sign with a highlighted green. So first of all, like before, I can see that I have a common denominator. And my answer then is going to have that common denominator in it. Whoops, well, I made it a little large. We're going to need that, x plus 8. And now I'm going to subtract the pieces of the numerator. However, it's very important that I do this. This minus sign that I put in green here will be distributed into both sections of the second numerator. So we will come up with this first part, 5x minus 1, will stay intact. But now I'll take that green one and distribute that green negative into both pieces. So now I'll have minus 3x and minus 4. So I needed that big long division bar because I had a large numerator. So the only thing you have to be careful of is just making sure you distribute a negative sign if there's two or more terms. One term, two terms. Okay, so we have to distribute that negative into both. When I do that, now I can combine my like terms. So now 5x minus 3x is going to be 2x, and negative 1 and negative 4 is negative 5 over x plus 8. I am done. Don't try to cancel those x's. I see I have trouble there. I can't do it between those addition and subtraction signs. So that is the final answer because nothing else factors to reduce, unlike the previous question, example 4, where that 5 came out and reduced. As we move to the other bottom half of this page, you'll see we have some more addition and subtraction where we have to find the common denominator. So if I gave you an expression like 1/4 over here to the right, and I told you to add it to 1/7, you'd say, wait a minute, I need a common denominator. I can't add the 1 plus the 1 and the 4 plus the 7. So I use a common denominator, the least common denominator, called the LCD of 28. So let's look at my first example. My LCD here is 5x. Okay, so I'm going to take that 1/5 and I'm going to leave a little room and I'm going to add it to 3 over x. But now I'm going to take my common denominator of 5x and place it next to each one of these because I need to make the common denominator out of the denominators I have. 5, the first denominator, is only a piece of the least common denominator. And on the second expression, 3 over x, the x is only a piece of the common denominator. So I'm really asking myself, well, what part is missing? So let's come to this first expression. I got the green little marker very lightly. What did I have to multiply the 5 to get it up to that red 5x? Well, I needed to multiply it times an x. And I'm going to compensate my numerator with that same x. And when I multiply that 1 times x, I come up with x. And I do the same thing to the right. I look at my common denominator. We'll go with blue. Okay. Got x and 5x. What did I have to multiply that denominator to, that x by, to get it up to 5x? The number 5. And I'll compensate the numerator with that same number 5. And when I multiply that numerator together, I come up with 15. So now I'm going to look at just what I have in red. X over 5x plus 15 over 5x. And now I can see, oh yeah, now that I have a common denominator, I can say, all right, my final answer is going to be over 5x. And now I just need to add my numerators together. And when I do that, I get x plus 15. We are done. Don't try to cancel that 15 and that 5. Don't try to cancel those two x's. Okay, we have a plus sign in that between that x plus 15. That is the final addition. If we do the same thing for example number 7, it looks like it's a completely different problem because we have a whole number next to a fraction. Just remember, any whole number can always be made into a fraction by putting it over 1. So now when I look at that problem, I really am going to look at it like 7 over 1, leave a little space, plus 9 over x. And I need to find that common denominator. That common denominator is 1 times x, which is x. So the least common denominator is x. So I'm going to put an x next to that first term and ask myself, well, what did I have to multiply by? I'll use that green. What did I have to multiply by? That 1 to get it up to x. X. And let me compensate that numerator with the same thing. So I come up with 7x over x in blue. And now you're going to say, all right, we'll do the same thing on the other one. I don't have to, because I already have the common denominator. I don't need to compensate 9 over x because it already has the least common denominator. So my result in blue is to take that 7x over x, take this red addition sign and make it blue, and make that red 9 blue. And now I can add those because I do have a common denominator. It is x, and I'll put it down below. And now I'll combine my numerator pieces between my two fractions and put them together as one fraction. That problem is done. Nothing else cancels as well. Let's look at the last problem on that page, and then I think we'll stop the video and we'll do a part 2 video for the last couple pages of this review. So let's see, what can we decide our least common denominator is in example number 8? Well, I have an x and I have an x squared. The least common denominator, some of you guys might say, well, why don't you just multiply those guys together and get it up to x to the third? Well, that's a common denominator, and actually it could work, but it's not the least. The least common denominator is the x squared, not x, because I can't bring something, I'm trying to multiply to bring these denominators up to what they're supposed to be. So the least common denominator is really x squared. So I'm going to take that first expression and, oh yeah, I better leave a little room, right? Let me get that out of there for a second. Okay, because you know I need room for that common denominator. So I'll just come over here and put the minus over here. Take the 7 over x squared. So we're saying that x squared is the least common denominator. I'm going to put it down over here and ask myself, what do I have to multiply my denominator in red? What do I have to multiply that by to get it up to x squared? I'll use green again. I have to multiply by x. And I need to compensate the top with the same thing. So that numerator on the top becomes 3 times x. And that denominator is that least common denominator of x squared. And once again, look, the second fraction automatically has the x squared. It already has the LCD. So my calculation is going to be that 3x over x squared. I'll take that minus sign. And the second fraction of 7 over x squared. And I know since I have that common denominator of x squared, I got something up in the numerator over x squared. And it is 3x minus 7. And that's simplified. That's the answer. So we're going to stop there because the video will be too long when I make a YouTube video out of this. And we'll do the last 2 pages on video part 2.